given question number 50. Okay. So remember, compound that cannot be obtained from aldol condensation reaction given below. Do you know aldol condensation? Alpha hydrogen containing carbonyl compound show aldol condensation. Everyone know? Alpha hydrogen containing carbonyl compound show aldol condensation. Okay. So now remember here how to solve this question. Okay. How to solve this question? Now it is given C double bond cyclopentane, C double bond here. Okay. Here no alpha hydrogen is present. Both are methyl methyl. Bond line notation everyone know. Both are methyl methyl here. That's why here no alpha hydrogen is present here. Okay. But this side alpha hydrogen is 2 here. Alpha hydrogen is 2. For aldol condensation we require 2 alpha, at least 1 alpha hydrogen. Here's 2 alpha hydrogen. That's why it shows aldol condensation. Now react with benzaldehyde. Okay. It react with benzaldehyde. So now react with benzaldehyde. Now it is phenyl. It is C double bond H here. Okay. What is given here? C double bond H here. Okay. Now in presence of NaOH, what is given here? NaOH plus heat. Okay. Now it is given sodium hydroxide plus heat is given here. Okay. Now basic medium. Okay. So now base extract to alpha hydrogen. Now formation of carbon acid. It is formation of carbon acid. Okay. So remember here step first formation of carbon acid here. Okay. So now what product is formed here? C double bond O negative charge is here. Formation of carbon acid. Okay. Carbon acid, that means nucleophile. It is nucleophile. What is the mechanism of aldehyde ketone? Nucleophilic addition reaction. Everyone know what is the mechanism of aldehyde ketone? Nucleophilic addition reaction. So now this react with benzaldehyde. It react with benzaldehyde. Okay. C double bond H here. Now shifting of this bond. Okay. Negative charge, positive charge. Nucleophile attack on this positive charge species. Okay. What product is formed here? Now it is C double bond as it is group here. Now attach on this molecules. Okay. So now here negative charge, here is hydrogen, it is phenyl. Okay. Now this phenyl group, benzene is here. Okay. Now this hydrogen, remove hydrogen attack on this negative charge. Okay. To formation of this product. Okay. Formation of this product, C double bond, it is OH, it is hydrogen, it is benzene ring. Okay. Now it is condensation product. Okay. Now aldol product, it is aldol product. Now condensation, we require condensation. Condensation means heating. Okay. Heats and condensation. So now on heating it form functional group. It is alpha carbon, it is beta carbon. Okay. So remember here alpha hydrogen abstract is lone pair. So lone pair is base nucleophile. Nucleophile attack on electrophilic alpha hydrogen. That's why here negative charge. This lone pair of oxygen attack on H positive ions here. Okay. So now here what product will form? C double bond methyl. It's a negative charges here. Okay. After removal it becomes hydronium ions because this H positive attack on this lone pair of oxygen. That's why here phenyl. That's why here phenyl. Okay. Now hydronium ions is a very good leaving group. So removal of water molecules from here. Okay. So here positive charge. Removal of this group it becomes positive charge. Now C double bond here, it becomes a double bond here, it becomes 2 phenyl here, as it is phenyl here, here is hydrogen. Okay. So now pi bond is formed between alpha beta carbon. Okay. So remember here pi bond is formed between alpha beta carbon. So remember this trick. In aldol condensation pi bond is formed between alpha beta carbon. Okay. So now here is alpha, here is beta carbon. So pi bond is formed between alpha beta carbon. Okay. So now which option is correct? Remember here it is given phenyl. Okay. First is given phenyl here. Okay. It is phenyl here. C6H5 is double bond. So now first option is correct. Okay. Second. Now remember here cannot be obtained. Okay. First is can be obtained. It is cross aldol condensation. Both are different. It is cross aldol. Okay. Now suppose here self-aldol condensation causes. It causes self-aldol condensation. What product will form? Understood everyone? So now remember first option is correct because cross product will be this. Okay. It causes self-aldol condensation. It causes self-aldol condensation. Both are same. It is cis form, trans form. It is show geometrical transform. It shows geometrical different valency here. That can write here cis form. It is cis form. It is trans form. So both are correct. Okay. Remember here cross aldol condensation. Okay. It is cross product. It is cross aldol condensation product. It is cross product. Okay. Now self-alone condensation, what will be product? Self-alone condensation. Remember here both molecules are same. We taken same molecules. Suppose we taken here same molecules. Now C double bond here, CSC, CH3 here. Okay. So both molecules are taken same here. Okay. Now C double bond, CSC, CSC here. Okay. Now one molecule's base react with sodium hydroxide base abstract to alpha hydrogen. So now remove of alpha hydrogen from here. So negative charge. So negative charge are take on positive charge species. Okay. So what product is formed? So now remember this. It is form O negative charge here. It is methyl methyl and this carbon are take on this. Okay. So what product is formed here? C double bond CS3 here. CH3 here, CH3. This negative charge are take on this nucleophilic addition reaction. What is making nucleophilic addition reaction? Okay. So now product what is here? Hydrogen removal hydrogen take on this. That's formation of alcohol. Okay. Again here alpha beta. It is alpha carbon. It is alpha carbon. It is beta carbon. Again hydrogen abstract from this. I take on this in formation of pi bond. So again condensation after heating. It form condensation product. What will be condensation product? Condensation product will be double bond here. Here is C double bond. Here is CH3, CH3. Okay. So now this is self-alone condensation. So check here. Self-alone condensation. It can show GI also because different group, different group. It can show. Okay. Now it is also correct. Now it is also both are correct. This is correct, but this is not possible because this pi bond is formed between it is alpha. It is alpha, beta, gamma, beta and gamma. So not possible. It is not possible. Understood? Beta gamma is not possible here. Okay, so remember here fourth option is incorrect. Okay, what is the answer here? Fourth option is incorrect here. So remember here fourth option is incorrect. Okay, so cross product will be this, cross product will be this. Okay, so now next, so remember here cross product will be this here. Okay. Remember here cross product will be this. Okay. What is here cross product? So now fourth option is here. Fourth option is correct. Okay. Incorrect statement because this is not possible. It is alpha, beta, gamma. Pi bond is between beta, gamma. Okay. That's why here not possible. That's why here not possible. Okay. Next question 51. Okay. Now we discuss 51 question number 51. So now what is 51 question here? Remember what is question number 51? Okay. Now it is given for salt XY, which is a strong electrolyte. Okay. So do you know infrared dilution D by Huckel-Ohn-Sagar equation? Okay. Do you know this equation? D by Ohn-Sagar equation. Equation, you know. Equation. Remember here, for molar conductance, at C concentration, molar conductance, infinite dilution. Okay, molar infinite dilution minus B into its B is constant, D by Huckel constant root C. Now this equation. Okay, everyone know this formula. Molar conductance C concentration. Here is molar conductance C concentration. Molar conductance, which of the following electrolyte? Molar conductance is given here. C concentration, infinite dilution. B is constant, C is concentration here. Okay. So what is here? We have to find out molar conductance dilution going on 145. Its value is going on 145. Okay. We have to find out infinite dilution. We have to find out molar conductance infinite dilution. Okay. What is B here? My 90 value. 90 value is given. To put here 90 value. What is C value here? C value is given 0.01 concentration here. Okay. So limiting molar conductivity 298 Kelvin we have to find out. Okay. Concentration is given 0.02. Now put here 0.02 10 to the power minus 2 here. Okay. And now 145 is equal to molar conductance of XY dilution minus 90. What is the root of this? 0.1 here. Okay, now its root is 0.1 10 to the power minus 1. 10 to the power minus 1 means plus power minus power cancel out, 9 here. Okay, so now 9 8 here. So now 145 plus 9 becomes 2 molar conductance. Molar conductance for dilution of XY salt. Okay, infinite dilution. Okay, so what is here? 154. What is here? 154. 5 plus 4 9. 154 molar conductance infinite dilution of XY here. Okay, so do you know, according to D by Onsager-Huckel equation, also the molar conductance C concentration, molar conductance infinite dilution minus B into root C. What is here? D by Huckel constant here B. Its value is given, so we can find out molar conductance infinite dilution. Okay. So now how to write molar conductance infinite dilution of any electrolyte salt XY. Okay. How to find out? Mole ionic conductance of cations X positive infinite dilution plus ionic conductance of anions infinite dilution here. Okay. Now its value is given. What is value is given? 154. Infinite dilution. Ionic conductance Y is given. We have to find out X is given. What is given? 74 here. So put here 74. So we have to find out equivalent conductance of NiT infinite dilution. We have to find out equivalent conductance of Y negative ions here. Okay. So now here 154 minus 74. Okay. So 154 minus 74. So we get equivalent conductance of Y negative infinite dilution. Okay. Subtract this value. What is value here? 154 minus 74 here. Okay. Now 0 here. Okay. Now it is 15. 15 minus 7 3 plus 5 8 here, 8 0 here. Okay. Now 80. So now what is value here? 80. Now where 80 molar conductance infinite dilution of Y negative will be 80. What is answer here? 80. So what's your answer? 80. So now remember here what is the answer? Fourth option is correct. So now 51 question, fourth option is correct. Okay. Very simple question. No need to write some equation. Just remember concept. Okay. Everyone know this equation we can find out first molar conductance infinite dilution. Everyone know molar conductance of any salt XY. So, molar conductance of cations, it is sum of molar conductance of cations plus sum of molar conductance of anions here. Okay. So put here just value molar conductance of cations, molar conductance of anions here. So now its value is given. Question already given, so we can find out molar conductance of Y negative. So we get molar conductance of Y negative will be 80. The answer will be 80 here. Okay. Now next question we discuss 52. Okay, what is 52 question number? Remember what is 52 question number here. Okay. Now given below are two statements. One is labeled as assertion and other labeled as reason here. Okay. The first ionization enthalpy of oxygen is lower than nitrogen and fluorine. Okay. So remember here nitrogen, oxygen, fluorine. Okay. What is question number 52. Okay. Now write electronic outermost electronic configuration. Everyone know 2p3. What is configuration? 2p3 here. What is here? 2p4. 2p4 here. P subcell. Okay. Now it is 2p5 here. Okay. So now it is everyone 2p5. Now it is half filled. It is half filled for first ionization enthalpy. First ionization and energy or enthalpy. First ionization enthalpy, yeah, energy. Okay. What is here? First ionization enthalpy here. Okay. Now first ionization enthalpy here. Now what's value here? Okay. This half filled. This half filled is more stable. Half filled is more stable. Half filled is more stable. That's why its ionization enthalpy greater than oxygen. That's why ionization enthalpy greater than oxygen here. So now is ionization enthalpy nitrogen, then oxygen. Okay. Then fluorine is highest. Fluorine is highest, then nitrogen, then last oxygen. Okay. Understood everyone? Why here fluorine? Remember here. Remember here. Remember here. Fluorine is more. Okay. If half-filled configuration is present, its ionization will be greater than atomic number 1 only. What is atomic number here? 7. What is atomic number here? 7 only. Okay. Now atomic number is 7. Atomic number 8. Atomic number 9. So now half-filled orbital always ionization energy increases corresponding to atomic number 1, not atomic number 2. It is greater than atomic number 1. only, not greater than 2, not greater than 2, not greater than 2 is not possible, not greater than 2 is not possible here, okay. Remember here, first ionization enthalpy of fluorine, nitrogen, oxygen, okay. Fluorine, oxygen, nitrogen here, okay. That's why here, first ionization enthalpy fluorine, nitrogen, oxygen. So oxygen is lower than nitrogen. Correct statement. Okay. Second, the loss of electron from oxygen lead to stable half-filled p orbital. Okay. So loss of electron from oxygen. So remember here, one electron, second ionization energy. Okay. So now here 2p3 here. Okay. So now second ionization, they are asking about second ionization energy after loss of one electron. What is configuration here? 2p2 here. Okay. What is configuration here? 2p3 here. What is configuration here? After loss of one electron, after loss of one electron here, after loss of one electron here. So now it is 2p4 here. What is here? 2p4. That's why here second ionization enthalpy oxygen is greater than fluorine. What is order here? Oxygen, then will be fluorine, then will be nitrogen. So second ionization enthalpy order will be this. Okay. So now loss of electron from oxygen lead to half-filled p orbital. So it's correct. Loss of one electron, it becomes half-filled orbital. So both statements are correct, but not explanation is correct. Why not explanation is correct? Because in first case, nitrogen is half-filled orbital. Okay. In half-filled orbital, atomic number 1 will be increases ionization enthalpy. What is atomic number 7 here? So it is greater than 8, not greater than 9 here. That's why it is. So remember, first, second option is correct, but not explanation. Okay. So first assertion is not correct, but not correct explanation of assertion. That's why first option is correct. What is the answer? First. 52. Answer is first. What is the answer here? First option is correct here. Okay. First option. Because explanation not correct. Explanation is not correct. Not correct explanation of A. Why it is? It is simply why ionization energy are lower? Because it is not half-filled orbital. Okay. Half-filled orbital in first ionization energy, it is not half-filled orbital, but in second ionization energy it gained half-filled configuration. That's why ionization energy greater than fluorine. That's why here both statement is correct, but explanation not correct. Understood everyone? Remember this concept. That's why here second ionization energy enthalpy order will be this. Answer will be first option is correct. Okay. Now question number 53. We discuss question number 53 here. Okay. Now, according to crystal field theory, the correct order of ligand with respect to their decreasing order of field strength. Do you know spectrochemical series? Do you know? Question number 53. Do you know spectrochemical series? According to CFT, do you know crystal field splitting energy theory? Spectrochemical series. How do I do a strong field ligand? Remember this trick. For strong field ligand, strong field ligand, okay. So remember this for strong field ligand. So now it is carbon, dotting side, carbon, nitrogen. Dotting side is carbon, nitrogen is present. That's why it is a strong field ligand. Dotting side is carbon, nitrogen is known as a strong field ligand. So remember here, first identify here. It is not chlorine. Carbonyl compound is strongest ligand. Everyone know? Carbonyl, ethylene diamine. It is strong field ligand. Okay. So now here CO. What is weak field ligand? CO then nitrogen. What is here? Trick. Carbon, nitrogen, strong field ligand. That's why here CO. CO is strong field ligand. Then will be ammonia. Okay. Here's ammonia. Okay. Then CO and ammonia. CO, ammonia, only one option is given here. Okay. That's why fourth option is correct. Then will be water. Then will be Cl negative. So what's your answer? Answer will be 4. Your answer will be fourth. The correct answer will be 4 here. Okay. 53 question, fourth answer. So remember, according to spectrochemical series, if donating side is carbon, then is strongest ligand, then nitrogen, then phosphorus, then sulfur. Remember, what is trick here? First carbon, nitrogen, then phosphorus, then sulfur. The strong field ligand. Remember this trick. Okay. Remember this trick to memorize strong field ligand. Okay. Oxygen, halogen is weakest. Halogen is weakest ligand. Okay. That's why halogen last. Okay. So remember this. Now next question we discuss 54. Okay. Given below two statement are here. Okay. Now what is given? Given below two statement. First statement FeOX whole thrice is chiral. Second is given chiral. Okay. Do you know octahedral complex? It is octahedral bidentate ligand. Fe oxalato OX whole thrice. Okay. What is charge here? -3 charge is here. Okay. Oxalato is bidentate ligand. That's why coordination number 6 here. Do you know oxalato? C double bond O negative charge here. C double bond O negative charge here. It is oxalato. Okay. It is oxalato ions. Oxalato ions. Okay. It is bidentate ligand. It is bidentate. It is bidentate ligand. Bidentate ligand. Okay. It is bidentate ligand. It is bidentate ligands. Okay. What is coordination number here? 3 bidentate. That's why coordination number 6 here. So what is coordination number 6 here? Now it is coordination number 6 here. Okay. Remember bidentate ligand coordination number 6 here. So what is coordination number 6? Either strong ligand or weak ligand always form octahedral geometry. Everyone know? Either strong field ligand or weak field ligand. It is weak field ligand because dotting side is oxy here. Either strong or weak field ligand. Remember, either strong or weak field ligand. Either strong field or weak field ligand. Okay. Strong or weak field ligand always form sp3d2 hybridization octahedral geometry. So draw here octahedral geometry. Okay. So now it is chiral. Now, why it is chiral? And transform. It is given first is chiral. It is not given cis and trans, but it is cis form. If cis form is given, that chiral. It is transformed, that's why it is cis. It is misprinting. Cis form. Cis form is given. That's why chiral here. Okay. So draw it cis form. Everyone know in octahedral geometry, ligand never attach 180 degree. So now here Fe metal is present here. What is present here? Fe metal. Okay. Now here oxalato ions is present. Now here OX molecules but here OX molecule attach here. Now here OX molecule 3 oxalate ions are present here. Okay. So remember here it is different plane. Remember here it is up plane. Now it is up plane, it is down plane. It is up plane, it is down plane. Okay. Remember here it is up plane, it is up plane, it is down plane here. It is up plane, it is down plane here. Okay. That's why no plane of symmetry. Remember here. Suppose I will explain one example. Remember it is square plane structure. Okay. Remember here is square plane structure. Okay. Assume it is a square plane structure. Okay. So now it is a square plane structure. Now it is axis. It is axis. Okay. So now one group is here oxalate. Now one oxalate here upside. One oxalate upside, one is downside. That's why no plane of symmetry. One oxalate upside and one oxalate downside here. Do you know this upside? One oxalate here. How many bond? Square plane 4 side is present. 1, 2, 3, 4. Okay. One oxalate attach here. This position. One oxalate here and one oxalate backside here. One oxalate backside here. So that's why up and down. That's why no plane of symmetry. Now here no POS. Okay. No plane of symmetry. Okay. No POS, plane of symmetry here, no COS, okay, center of symmetry is no plane of symmetry here, no center of symmetry. That's why it is optical active. Cis form, it is cis form. Remember here, does not show cis and transform. Just remember here, it is oxalato. Either cis or transform, no plane of symmetry, no center of symmetry. That's why optical active. That's why optical active. No POS, no COS. That's why optical active chiral center. That's why it show chirality. That's why it show chirality optical active. It is optical active. It is optically active. Optically active. So remember this point. Either cis form or transform doesn't matter. It is not show always transform. Cis form is not possible because all group are same. All group are same, oxygen. That's why only transform is possible. Okay. So remember, it does not show geometrical, only show optical isomers due to no plane of symmetry, no center of symmetry. That's why it is optical active. Remember optical active here. Okay. Now second question. First option is correct. Now transform. Now we have to form transform here. Okay. Understood? First concept clear. Now second form. Now again coordination number 6. 4 plus 2, 6 here. Again octahedral, 6 coordination number octahedral here. Okay. So draw here octahedral geometry. Okay. So now draw here oxalate. Okay. So now here chromium. What is here? Chromium. So now here chromium. So now chromium here. What is here? Chromium. So now Cr here. Now it here chromium. Okay. What is we have to requirement? Transform. We require transform. That's why here one oxalate OX attach here, OX attach here, OX attach here. Okay. And one Cl, one water is given. That's why water here. Here is water. Here is water. Do you know how to identify cis and transform? Both are same. Oxygen, 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 oxalate, oxygen, oxygen. What is oxalate as? C double bond O negative charge. C double bond O negative charge. Both are donating side oxygen here. Both are oxygen donating side. That's why here oxygen, 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 water, water, oxygen, oxygen. That's why transform. Okay. Transform is transform chiral, not chiral, plane of symmetry. Remember, you cut into two equal parts. Okay. To plane of symmetry, cut into equal parts, both are superimposable. That's why plane of symmetry optically inactive. Okay. Plane of symmetry this side are cut into this portion, cut into this side is also possible. Okay. Remember, here the plane of symmetry. And now plane of symmetry both side. Now P was this side, P was this side. That's why it's optically inactive. That's why it is optically inactive. The molecule will be optically inactive. Molecule will be optically inactive. Optically inactive. So that's why here molecule is optically inactive. So option second is wrong here. Okay. Chiral molecule optically inactive due to plane of symmetry here. Plane of symmetry. Even center of symmetry also present. Remember, what is center of symmetry? Distance from center to axis are equal. Okay. So now here chromium. Here is chromium. Here is chromium. Here is water. Here is water. Distance always equal. Now suppose distance is given L1 distance. Now here oxalate. Oxygen is given down inside. Here oxygen donating side, here oxygen donating side, here oxygen donating side. Okay. Now distance L1. Now it is L1 distance, L2 distance, L3 distance, L4 distance, L5 distance, L6 distance. Okay. So distance from center to axis are equal. That's why center of symmetry is also present. Okay. That's why here this distance same, this distance same. All distance are same. That's why COS and POS both are present. Both are present. That's why it is optically inactive. Optically inactive. That's why it is optically inactive. Optically inactive. That's why it is optically inactive. So remember this concept. That's why it is optically inactive. Okay. So remember, first option is correct. Second is incorrect statement. So now first option is false. Both statement first and second statement are incorrect. Wrong. First statement correct. Second statement correct. The second option. The answer will be second. What is the answer here? Second option is correct here. Okay. So remember, second option will be correct here. Understood everyone? So remember, if three bidentate ligands are similar, it does not show geometrical isomers because always show transform, not show cis form. But it show optical isomers. Why optical isomers? Because why it show optical isomers? Because different plane. Understood? Remember this point. It is axis. This axis. The one is present upside. What is here? Upside. One is present upside here. Okay. One oxalate upside here. One auxiliary upside, one downside. That's why here no plane of symmetry, no center of symmetry. That's why it is optically active. So remember this concept. Okay. Now next we discuss question number 55. Okay. Next we discuss question number 55. For the following reaction sequence, choose the correct option. Okay. For the following sequence, choose the correct option here. So now it is given benzene. Okay. Question number 55. Okay. What is given here? Benzene here. Okay. So now it is given benzene here. Okay. So now benzene with acetyl chloride and aluminum trichloride. Now do you know Friedel-Crop acylation? What is here? CS3 C double bond Cl here. Now as Friedel-Crop acylation. What is here? Friedel-Crop acylation. Everyone know? Friedel-Crop acylation here. So remember here CS3 C double bond Cl is given in presence of aluminum trichloride. Okay, that's why it is formed formation of electrophile. Which electrophile is formed? CS3 C double bond positive charge as a electrophile. What is here? Electrophile is formed. Friedel-Crop alkylation. Okay, what is mechanism of this reaction? ESR, electrophilic substitution. What is mechanism here? ESR mechanism. Okay, so electrophile attack on this, shifting of this pipe. Okay. So remember shifting of this pi bond, shifting of this pi bond here. Okay. So remember here shifting of this pi bond, shifting of this pi bond. Okay. So now here negative charge, here is positive charge, here double bond. Electrophile attack on negative charge. Okay, everyone know electrophile rhenium sigma complex is formed. Everyone know mechanism of ESR. Do you know what is mechanism here? First step, formation of electrophile. What is ESR mechanism? Do you know mechanism of ESR? First formation of electrophile. So now CS3, C double bond Cl. Okay, now it is Lewis acid. Aluminum trichloride is Lewis acid. So now Lewis acid abstract to Lewis base. Okay, you know, to formation of electrophile, it forms CS3, C double bond O positive charge plus aluminum trichloride Cl4 negative here. Okay, formation. Now formation of electrophile. Okay, first step, formation of electrophile. Now second step, attack of electrophile. Formation of electrophile. What is here? Formation of electrophile. Here, formation of electrophile. Everyone know? Attack of electrophile here. Okay. Second step, attack of electrophile on a ring. Okay. Now here, CS3, C double bond positive charge species. Now shifting of this bond. So after shifting of this bond, we get this structure. Here negative charge here. Here is positive charge. Here double bond, double bond. So CS3 attack on this. Okay. So now formation of sigma complex intermediate non-aromatic species. Everyone know CSC, CS3. Here is positive charge, double bond here. Now what is hybridization here? sp3. Non-aromatic species, non-aromatic species form. Non-aromatic species form sigma complex. What is intermediate form? Sigma complex. They ask many times. Sigma complex. It is sigma complex. Sigma complex non-aromatic species form. Okay. Now step third. Stronger electrophile replaced to weaker electrophile. Okay. Now third step. Attack of electrophile. Attack of electrophile. Here. Attack of electrophile. Okay. Now third. Stronger electrophile substitute to weaker electrophile. Stronger electrophile substitute to weaker electrophile. Okay. Now this reaction is given here. Okay. Now here is given C double bond CS3. Now double bond positive charge is here. Okay. Now it becomes aromatic. H positive ions removed from this and formation of negative charge. So what is here? Acylation. Okay. Now it is acyl group is attached. Okay. Acetophenol. Acetophenol is formed. Okay. So what is final product? Acetophenol. Okay. Now this reaction react with NaOCl, sodium hypochlorite. Okay. Now acetyl chloride further react with, remember here. Now this is final product. Now this is after reaction we get this product. Okay. CS3. Now it react with NaOCl. Okay. NaOCl. Okay. What is here? NaOCl. Base plus halogen. Everyone know base NaOH plus X2 is Cl2 here. Okay. So now step first. Here is sodium hydroxide. Here is sodium hydroxide. Now sodium hydroxide X2Cl2 to formation of hypohalous acid, hypochlorous acid. One hydrogen removed from here and HCl. HCl is formed. Okay. So remember this hypohalous, that means haloform test. It is formed haloform test. Okay. So chloroform test, chlorine, that's why chloroform test. It is chloroform. Chloroform test. What is here? Chloroform test here. What is test name? Chloroform test here. Okay. Understood everyone? So now here is chloroform test. Here is chloroform test here. Okay. So remember here, this chloroform test here. Understood? What is test here? Chloroform test here. Okay. So remember how to form chloroform reaction. Step first. Now CH3, CH is given 3 hydrogens present. Okay. So now this base. Okay. Base abstraction of NaOH. Okay. NaOH. This base NaOH negative. Abstraction of this hydrogen. Okay. And addition of Cl negative attack on this. Okay. Now it is positive charge here, negative charge here, negative charge attack on this. Okay. So complete chlorination. First step, complete chlorination. What is here? Complete chlorination. Here is complete chlorination. chlorination. What is the step here? Complete chlorination. That's why here, which product is formed here? What product is formed here? C double bond C, Cl, Cl, Cl here. Complete chlorination. Okay. 3 mole is the requirement here. How much more? 3 mole of base is requirement here to formation of complete chlorination. Okay. Now step second, oxidation. Attack of C double bond NaOH base. Okay, base attack on this. So now second step is given here, C double bond Cl. Here is given Cl. Here is given Cl, and attack of OH negative. Okay, NaO negative. OH negative. Attack on nucleophilic addition. Removal of this charge. Okay, again nucleophilic addition reaction here. Okay, to formation of this, what is here? C negative charge here. Here is Cl, here is Cl, here is Cl, here is positive charge. Okay. So now negative charge attack here, it is removal of this negative group. Okay. So what is here? Attack of this O negative. That's why here O negative ON attach here. Okay. O negative and removal of this group. Okay. Third step, removal of this group. Okay. So what is step third? Step third, this group will be removed. That's why it forms sodium salt of acid here. Okay. What is product is formed? C double bond ONA, sodium salt of acid, plus here Cl, Cl, Cl. Negative charge is here. What is here? Negative charge. Okay. Now here HCl. HCl H positive attack on this. That's why form chloroform. So what is here? CHCl3. CHCl3 chloroform. We can write here CH3. Okay, CHCl3 chloroform plus what is final product? Sodium salt of acid here. Okay, C double bond ONA. Now sodium salt of acid plus chloroform is formed here. Okay, so remember here. So what is here? NaOCl. So remember here, again here H positive. That's why sodium replaced by this. It again convert to H positive is present HCl. Now its form convert to acid. So now final product is benzoic acid plus chloroform. Benzoic acid plus chloroform is removed. So remember here trick. Okay, remember here trick. What is trick? No need to write all equation. Just remember this trick. Okay. What is here? Remember this trick. Now alpha hydrogen. It is alpha hydrogen. C double bond alpha carbon OCH3. CH3 replaced by ONA group. CH3 replaced by ONA group. Remember, whenever CH3 group is given, so now it is attached ONA. Here is attached ONA only. CH3 replaced by ONA. Okay. So what is here? CH3 replaced by ONA, and second this CH3 convert to chloroform. This CH3 convert to chloroform here. Okay. So remember what is here? Benzoic acid is formed. Okay. Final product. So now P is what is here? Chloroform. It is benzoic acid. What is final product? P and Q. P is chloroform and Q is benzoic acid here. Okay. So now PQ are aromatic compound. Wrong statement is not aromatic. One is aromatic, one not aromatic. P give carboxylic acid on acidification. Okay. So remember it is given acidification. Carboxylic Q give poisonous gas.